Welcome to Mr. Hamilton's Math Bites. This video is about solving quadratic models. To solve a quadratic equation means to find x values that make a statement true. In general, we want to rearrange in the form ax squared plus bx plus c equals 0. Now, we do that by letting the function equal 0. We have to let that be the case if we're trying to solve it. So we're trying to find, in essence, what the x-intercepts are of a function such as this. And we do that by letting the function value be 0. We're trying to find those x values. We then determine the zeros of the equation, as shown down below. This can be done in many ways, including graphing to find the x-intercepts, as I've done on the right, factoring, which I hope we're very familiar with by now, the quadratic formula, that dreaded equation x equals negative b plus minus the square root b squared minus 4ac divided by 2a. I hope you're finding that equation is less dreaded these days as you're getting more familiar with it. If an exact solution is required, answers should always be expressed as radicals, known as square roots, or rational numbers, fractions. So we may be asked a few different things. We may be asked to solve something that already is set up in that equals 0 form, or we may be asked an application question, which we'll come to a little bit later. Let's solve a number of different forms. This first one, we have x squared minus 8x plus 15 equals 0. It's already in that form that we want, so all we have to do is solve it by either factoring it or using the quadratic formula. I guess we could graph it as well, but that's not practical for us here when we can factor it very quickly. So I need two numbers here because it's a simple trinomial that add to negative 8 and multiply to 15. Two numbers that add to negative 8 and multiply to 15 are negative 3 and negative 5. So then I go ahead and I just factor that directly because it's a simple trinomial. I write my x and then I leave my negative 3 space open and my negative 5 space open. I just write those in. Which means that x minus 3 equals 0 or x minus 5 is equal to 0. Which means x is equal to 3 or x is equal to 5. And we found both of those solutions very quickly in that way. A second case, again, we have x squared minus 8x plus 2, involves, again, always starting at that same starting point. Can we factor it? Two numbers that add to negative 8 multiply to 2. And we might think about that for a little while, and there are none. Which gives us a bit of a problem. We can't factor it, so what do? We move to the quadratic formula. The quadratic formula, as written above, is this. Don't forget that plus or minus, because that matters. It gives us two different solutions, as we typically get for a quadratic. Now, the b value is negative 8, so it's negative 8. And then we divide by 2 times the a value. Under the square root, we get negative 8 squared is 64. We subtract 8 and we divide that by 2. Now I needed a little more space to finish this because this actually isn't in the simplest form. We can take out a factor of 4 because 56 is 4 times 14, and then we can go ahead and write it as 8 plus or minus 2 root 14 divided by 2. So the solution is actually, if we divide 8 by 2 and 2 by 2, 4 plus root 14, or 4 minus root 14, which isn't quite fitting in on my screen there. 4 minus root 14. There we go. Now we have a situation where we don't have something in the ax squared plus bx plus c form. So what we need to do in this case is we need to first of all expand it and get it in that form. This is a perfect square, x minus 4 squared. So that just gives me x squared minus 2 times a times b plus b all squared. And that's equal to 2x minus 9. Now you could go ahead and expand that out directly all in one step, but I did that just so you can clearly see that form of the perfect square. It's becomes 8x, and plus 16, that's equal to 2x minus 9. Now what I need to do is I need to get it in that equals 0 form. So I'm going to subtract 2x from both sides, and I'm going to add 9 to both sides. And what that's going to do is it's going to cancel the 2x on the right side. It's going to cancel out the negative 9 on the right side. I'm going to be left with 0. So I'm going to get x squared minus 10x plus 25 equals 0. So we go to factor that, and we need two numbers that add to negative 10, multiply to 25. Well, those two numbers have to be negative 5 and negative 5. This is a perfect square. So what this becomes is just x minus 5 times x minus 5 equals 0, which is just x minus 5 squared. And we only have one root. This means that the vertex must lie on the x-axis. And because it opens up, because we have x squared term, we would therefore say that it has to be a minimum at the x-axis. If in fact we're graphing a function. This is just an equation we're solving, so it's not technically a function, but if it were, this is what we'd find. Let's look at our final example. We now have something that's not a simple trinomial. We have an a value of 3. So in this case, we want to again try to factor first, find two numbers that add to 11, but multiply to 3 times 6, because it's not a simple trinomial. That's 18. Two numbers that add to 11 multiply to 18 are 9 and 2. And then we go ahead and break that down using decomposition. That middle term, 11x, becomes plus 9x plus 2x, or plus 2x plus 9x, the order doesn't matter, plus 6 equals 0. Common factoring out of the first two terms, we get a 3x, and we're left with x plus 3. Out of the second two terms, we factor out a 2, we're left with x plus 3. These two are the same, that's good, that means we've done it right, and that's equal to 0. Which gives me x plus 3, that's the common factor, times 3x plus 2 equals 0. So that means x plus 3 is equal to 0, or the second possibility is that 3x plus 2 is equal to 0. So that means x is negative 3, or x becomes negative 2/3. Now our last question is a word problem. And this has to do with finding the width of an area around a rectangle. In this particular example, we have a swimming pool with a deck around the outside. So here's our pool. If I can find my mouse. There it is. There's our pool, and here's the deck around the outside. All the way around is the deck. So it then says a swimming pool has a deck around the outside of equal width. So that means this width has to be the same as this width, which is the same as this width, which is the same as this width. That's the fundamental assumption that's built into all these types of problems. Sometimes instead of a pool, you might have an area of grass that has been cut in the middle and an area that has been uncut around the outside. But the principle is still the same. We're asked to determine the value of x if the area of the deck, the word is kind of cut off on the video there, but if the area of the deck and the swimming pool are the same. So if this is the x value representing the width, what is the area, or what is the value of x? Well, there's a few more pieces of information you would need in a situation like this. Obviously, some numbers are in play. One number that I'll give you here is the length. The length is 20, and the width is 12. This would be given in a question like this. And beyond that, you're told nothing else. So what we do in a situation like this is we want to write some type of expression in terms of the pool. In terms of the pool. So we'll call this A1. A1, the pool is area 1. And we'll call the other area around the side area 2, A2. So how do we write an expression in terms of the pool? Well, we go A1 is equal to length times width. Well, it's the length defined in terms of the L that we're given, but also subtracting the x values that we're given. So we need to subtract them. So the length in this case for area 1 is equal to 20 minus x on the left side minus the x on the right side, so 2x. The width of that pool is going to be that 12 that we have, but we need to subtract the x on the top and the x on the bottom. So that can be written in terms of 12 minus 2x. Again, 2x is there. Now, what is area 1? Well, we know that area 1 is equal to area 2. We're told that those areas are equal. And we're also told that the total area is the length of 20 and the width of 12. So if we want to figure out the total area, we can just go equal to 20 times 12. Well, 20 times 12 is just 240 meters squared. Well, if we have 240 meters squared as the total area, and the two areas that make up that total area are equal, well, that makes sense then that this must be half of the 240. So that means that area 1 is equal to 240 divided by 2, 120 meters squared. So now substituting that back into our equation, what we get is that 120 is equal to 20 minus 2x times 12 minus 2x. So now what we have is something that we can expand and put in that ax squared plus bx plus c form. I get 120. I'm going to keep that there for now. I'm going to expand this out. Using FOIL, I get 240 minus 40x minus 24x plus 4x squared. And what I can do now is if I subtract 120 from both sides, I can bring that to the right side. And so I get 0 is equal to 120 minus 64x plus 4x squared. Well, that's almost in the ax squared plus bx plus c form. So let me just change the order of those. All right, just put the 4x first and the 120 last. But you may notice something here. We could go ahead and factor that and try to find two numbers that add to negative 64 and multiply to 4 times 120, which is 480. But that would be something that we would do a little prematurely, because the first thing we always try to do when we factor is common factor. And that's going to make our job a lot easier if we common factor here. I'm going to common factor a 4 out. I'm going to be left with an x squared minus 16x. And then if I take a 4 out of 120, I get 30. Divide both sides by 4. The 4 is going to cancel out. You don't have to necessarily show this. It should be intuitive to you, but I'm just showing it to you if it's not obvious. I get 0 is equal to x squared minus 16x plus 30. Well, now I just need to find two numbers that add to negative 16 multiplied to 30. And it's a simple trinomial. Unfortunately, there are no numbers, so it's not factorable. So what we need to do is use the quadratic formula. So I'll just do that quietly in the rest of this video. So those are my a and b and c values, and then substituting them into the quadratic formula, we get this. Negative 16 gives me positive 16. Negative 16 squared minus 4 times 1 times 30 divided by 2 times 1. 16 squared is 256, I believe. So 256 minus 120 yields 136 under the square root. That's not quite done yet, because we can still take a perfect square out of the 136. We take a perfect square of 4 out of there. Four times 34, and divide by 2. So x is equal to 16 plus or minus 2 root 34 divided by 2. The 2 and the 16 cancel to give us 8, and the 2 and the 2 cancel to give us 1, so I get 8 plus or minus root 34. That's an exact, but that doesn't mean a lot for us. A physical answer will help even more. And so we get 2.17 meters as one possibility, or the other possibility is 13.83. The deck and pool combined only had a width of 12 meters, so 13.83 is out of the question. So our answer has to be 2.17 meters for the width.